Hello friends, welcome back to my channel Learn India 24/7. In this video, let's discuss and understand about statistical significance. We shall cover the below topics. So let's begin. Statistical significance is a way to determine that a difference between two or more variables is not just by random chance. For example, a farmer is trying to determine if the new food makes the pig gain weight faster. To test this, farmer try the new food on 10 pigs and old food on another set of 10 pigs. After a month of time, farmer measured the weight of all the pigs. Finally, farmer found that the pigs who ate new food gained more weight than the pigs who ate old food. Does this mean the new food caused increase in weight? Well, maybe the new food has caused increase in weight of the pigs. Or maybe you just happen to give the new food to the 10 pigs that were always going to gain the weight no matter what. How do you conclude this? Two important concepts in statistical significance are the distance the average value of your measured data is from what you are comparing it against, and the standard deviation of your sample. Standard deviation is an important measure to see the spread of data under study. With increase in standard deviation, the bell curve gets flattened, and with the decrease in standard deviation, the bell curves become narrow and data points are clustered close to each other. We have discussed these properties of normal distribution in another video called Basics of Hypothesis Testing. We are interested in the standard deviation of average value of all measurement we make, that is sample mean. The standard deviation of sample means decreases as we increase number of measurement we make, that is sample size. But why so? Let's understand this with the example of rolling die. Let's see the result we get when we roll one die versus two die and then increasing number of dice. If you roll a single die, you have an equal chance of getting values 1, 2, 3, 4, 5 and 6. So the probability distribution of single die rolled 6 times will have each value coming up one time. If you roll 2 dice, there are 36 permutations of dice rolls, 6 values from first die multiplied by 6 values from second die. There are 11 different sums you can get from those 2 dice, the values of 2 through 12. These 36 different die permutations don't map evenly on 11 different possible sums. We will get more values in the middle of range than values on the edge. The key point here is that the probability of outcome is more concentrated in the center of graph for 2 die rolls than it is for single die roll. The concentration of probability into the center of graph doesn't stop with rolling of 2 dice. If you sum the values of 3 dice, there are 216 different permutation of rolls mapped to 16 possible sum of values from 3 to 18 are possible. The probability distribution of 3 dice rolls is shown here. It is not quite obvious, but summing 3 dice has a greater concentration of probability in the center of graph than the sum of 2 dice. And this process would continue if we kept rolling additional dice. So far with these dice, we have talked about the sum of dice values. Now let's talk about the average value. The probability distribution of average value for 1, 2 and 3 dice rolls is as shown below. The plot makes few things obvious. No matter how many dice are rolled, the average value is always centered on 3.5. This is because the average of all number on single die is 3.5. As you increase number of die roll, the bulk of probability shift to the center of graph and it decreases drastically on the edge of range. In order to get consistent probability distribution, let's use histogram with binning method. The histogram doesn't plot well for 1, 2 and 3 dice roll. However, it plots well for 5, 10 and 20 dice rolls. You can see now, the greater the number of rolls, the more the probability distribution of average values is clustered around 3.5 and lesser on edges. We can in fact calculate the standard deviation of average for a given number of dice. For a single die, this is just the population standard deviation of outcomes 1, 2, 3, 4, 5 and 6, which is 1.7078. For a 2 dice, this is the population standard deviation of 36 possible outcome of average values, which is 1.207615. But there are more efficient ways to calculate the standard deviation than just listing out every single possible value. When you calculate and plot the standard deviation of the average for all number of dice between 1 and 20, you can see the graph as shown below. As discussed already, the standard deviation of the averages continues to decrease as we increase the number of samples. The other key point about this plot is that at one point of time, the rate of change begins to level off. Adding few more dice drastically reduces the standard deviation at beginning, but it takes more and more number of dice to get the same amount of change. In practical term, there is a diminishing rate of return for using more number of samples in your statistical significance. At the beginning, additional data will result in large change, but eventually the cost of acquiring additional data will not yield the equivalent amount of benefit. Now let's look at the same plot with regression fit of the data. The line of regression fits the data exactly. As per regression equation, the rate of change of standard deviation of average is equal to standard deviation of population multiplied by number of data points raised to power of -1/2. We can rewrite the equation as sample standard deviation is equal to population standard deviation divided by square root of sample size. In the regression equation, the value 1.7078 is the standard deviation of average values with one sample. Let's denote this by sigma. And x is number of dice. Let's denote it by n. With these symbols, the equation becomes standard deviation of sample y is equal to sigma divided by square root of n. So friends, let's discuss and understand the overall process of finding statistical significance now. To do that, let's first determine how many standard deviation is our outcome from the average outcome. Next look up that level of standard deviation in probability table to find how unlikely it is that the outcome would occur by random chance. There are a couple of different ways to find how many standard deviation an outcome is from the mean, and there are a couple of probability distributions to choose from. So friends, we have come to an end of this video. I have completely referred the book Hypothesis Testing by Scott Hadson to prepare this video. In the next video, we will discuss and understand about one sample chat test. So friends, finally, if you have liked this video, do subscribe to my channel and don't forget to press bell icon. Thanks for watching and bye.